Hey guys, welcome back. So today we're working on this 13 horse Honda clone. I recently pulled it off a Generac GP6500 and I think you can tell why. This engine was oversped and as a result the valves started to float. They couldn't get out of the way in time and the piston just started hammering the valves until one of them broke. And that valve got crunched, between the piston and the head, destroying both. That said, though, the rest of the engine seems to be in pretty good shape, and this one would be worth saving. It only has 64 hours of runtime on it. So my hope today is that by the end of this video, we will have this engine up and running again. So let me get you set up a little bit better and get going on this. So you may have seen this engine already in another video. I did an engine swap, basically pulling this out of the GP6500 and putting a good one in its place. But in that video, we did open the engine up and take a look at the internals, and the bottom end is in great shape. And surprisingly, the cylinder is in very good shape too. There is no scoring, no damage that can be felt, and there is plenty of crosshatch. So this block, I would say 100% is good. That said, though, I wasn't sure if I was going to be able to rebuild this. Luckily, Generac does stock and sell the parts we need. We need a piston, potentially a connecting rod, a head, 2 valves, and some miscellaneous things. But when I priced it out, it came to about $430. And when you factor in tax and shipping, it's closer to $500. And I can say with certainty that whatever generator this engine will go on is likely going to sell for $400 or less. So buying the parts from Generac doesn't make sense. But I don't want to throw this away either. I've taken apart a lot of blown up engines, a lot of Honda clones, and I've saved the good parts. And I think I have the parts I need to put this together for about $20. Just the cost of a new head gasket, a new sump gasket, and maybe a few miscellaneous things. But I do have, I guess, one big concern. Let me show you that. And this is the head that was on this engine. You can see the extent of the damage. That valve got hammered into the head. This seat is destroyed. Obviously, that valve is destroyed. And this one, although it's still attached, I'm willing to bet it's bent and weakened. So, yeah, this head is not good. Now, I do have other heads, actually 4 other Honda clone heads that will fit an engine of this size. I guess my concern is that this valve cover is rectangular. This is a Hemi head, which in this case really just means the valves aren't going straight down. They're actually angled, so they conform better to the spherical shape of the head. And the heads I have aren't like that, but I think the bottom end is the same. It's just the head that's different. So let me show you the heads I have. And what I'm thinking is we can just swap out the Hemi head for a standard one. And this is the style head I have. These are actually more common. You can see the valve cover is quite a bit different. And if I flip it over, if you look at the top of the head, it's actually not very spherical. It's actually pretty flat, and the valves are flat as well. That said, it has the same footprint as far as the sealing surface goes, and I've already test fit it, and it fits on and bolts on just fine. So I think we can swap the Hemi head for a standard head, which is good news because that's going to save, I would say, close to $300 just by doing that. Now, that still leaves the issue with the piston, and I think I have one of those as well. It's used, but I think it'll work. And this here is the piston I have. This was pulled from a GP5000, also 389 cc. So it has the same displacement. It is a Honda clone just like this. And I've already test fit this piston in the bore. And I think it's actually a perfect match. So we will double check that. I think the next move here is to get this engine fully apart. I cleaned up the inside a little bit. There were some pretty big chunks in there, but it needs a thorough cleaning. So we'll take the engine cover back off. We'll get everything out of the engine, clean up the block, and start putting this back together. This is just a piece of Scotch-Brite and a bit of WD-40, taking off the high spots so that when this comes out, hopefully it doesn't cause any damage to the oil seal. Just going to rotate this a little bit until the timing marks line up, and then we can pull out the camshaft and the lifters, being sure to keep track of which is which. The exhaust is the closer one, and the intake the far one. And we need to do the same for the counterbalancer. We have to rotate the engine a little bit further, and timing marks are now aligned. So if you don't do that, you might have issues clearing to get this piece out. And then we're just left really with the crankshaft. So let's get the cap off the connecting rod. And then we should be able to get the piston and the crankshaft out. That one's loose. Let's get them both loose before removing either one. I'm not sure that's going to work. We're too close to the gear, so I'm going to switch out to a ratchet. Things are looking really good. This crankshaft is pretty much perfect. The main journal looks great. The journal on this side is good. And the bearing, perfectly smooth. No noise at all. So the crank, 100% good. The counterbalancer also looks like new. So I'd say that is a good part. And the camshaft, the lobes look to be in very good shape. I don't see any issues there. The compression release is still intact, and there is a piece of metal right there. That's part of the piston. So, all these parts do need to be cleaned, but they seem to be good. And, well, lastly, we have the piston, which we know is bad. The connecting rod, though, actually seems fine, as well as the wrist pin. So we might reuse that, or, I guess we have a plan B. We could use that connecting rod. Now, the thing I'm kind of debating here is what to do about the rings. These rings are used, so we could get some new rings, hone the cylinder, and know we're good to go. And usually you do replace rings. They are a wear item. But this engine only had 64 hours on it. These rings have only just seated in the cylinder. And the cylinder's in fantastic shape. I don't think we need to hone it, and I don't think we need new rings. So what I'm leaning toward right now is just transferring the rings over and calling it good. So let's actually just get these rings off now. We'll drop them in the bore, we'll measure the end gaps, and if things look good, then I'm going to use these rings on that piston. Just double checking the diameter of this bore. We're close to 3.5 inches, and a good rule of thumb is about 0.03 of an inch end gap for every inch of bore. So in this case, we're looking at a minimum end gap of 11 thousandths, and a safer number would be 4 thousandths per inch. So that would be more like 14 thousandths end gap, minimum. It can be larger. Of course, you'll lose a little bit more compression, burn a little more oil. But if we're close to, 14 or 15 thousandths, I'd say we're pretty much perfect. And I can tell already that end gap's pretty tight. I'd say close to 15 thousandths. So let's start with a 15 thousandths feeler gauge. And no, that does not fit. So let's try a little smaller. Maybe a 13. Yeah, and a 13 fits. So we're somewhere between a 15 and a 13, which is basically brand new. So this ring has minimal to no wear. Let's check the second ring. And the second ring, it's normal actually for it to have a little bit more clearance on the end gap than the first ring. So we saw between a 13 and a 14, actually between 13 and 15 on the first ring. So I'm expecting this to be a little higher. And just looking at the gap, I can see that it is higher. So maybe closer to 17 or 18. So let's start with, I guess, an 18. Yeah, an 18 fits, but there is a lot of drag. So that ring, I would say, is 18, which is good. So these rings, I would say, can be used. So now starts the fun part of cleanup. So I'm going to get this oil sensor loose so we can move it out of the way. That way I'm sure there's chunks back there which we need to clean out. And actually this whole block I'm going to soak in soapy water and just get all the little bits out of here. Yeah, you can see all those chunks right behind the oil sensor. And another place they like to hide is actually in this passage here. Over on the other side, that's the bolt for draining the oil out. So I will pull the bolt and just make sure, we'll blow through that with air, make sure it's clear and no bits of metal remain. Those are in there. All right, that one's not budging. Yeah, these are kind of rust jacked in place, I think. It's going to be a problem, but they need to come out. We can always buy new ones. I think I have others, so I'm not overly concerned about saving these locating pins. I've never had pins in there so tight, so obviously these are not going to be savable, but now I'm just more concerned about how to get them out without causing damage. I think a slide hammer, potentially, if I can somehow adapt it to get in there. So let me double check what I have. Nothing. Yay. Never had to work so hard for a dowel pin. So one down, one to go. I think the key there was kind of folding over the end so that this could grab it a little bit better. This is meant to pull ball bearings from a blind hole. And on the other end of this tool is a lip that's supposed to go behind the ball bearing. So if it can't catch on anything, then the tool just comes right out. So we'll just fold this over like we did the other one. And hopefully this one comes out as well. There we go. The engine block's been fully cleaned, all that gasket material gone, and the block washed out with soap and water. Everything's been re-oiled, and the same has been done for the engine cover. So these two things, they are ready to go. Also, the crankshaft, the counterbalancer, and the camshaft have been cleaned and oiled, so those are all set. So we are getting pretty close. Really, the big outstanding item here is getting the rings moved over. So before I do that, though, I do want to run a few more checks and just make sure that that piston is going to work. Now, one thing to note, you can't just swap the head type without swapping the piston as well. The Hemi head Honda clones use a piston that is perfectly flat on the top. And if you're going to use a standard head, you need to use a piston that is dished like the one we're going to use. Anyway, I've been doing some checks between these two pistons just to see if the important parts are the same. And so far, most things are checking out. I did find one problem. I'll show you that in a second. But first, I checked the diameter, and this one is actually a few thousandths wider than the one we're going to use. So I think that'll be okay. I'd rather have it a tiny bit smaller than the other way around. The next big thing is the skirt. The skirts on this piston don't go down very far, whereas if you look at the piston we're going to use, they go down, I would say, a good ½ inch further. So that should be okay, but I'm thinking I want to loosely assemble the engine and just rotate it over and make sure that there's not going to be any interference. And at the same time, we can also check the deck height. When the piston's at top dead center, it should be exactly at the same level as the deck. If it extends too far or not enough, then we know we need to dig in and just double check the connecting rod to make sure that it is the same size. Now, the one thing I did find that is a problem actually has to do with the rings. I wanted to reuse these rings because these are the ones that go with the cylinder. And if I'm not going to hone it, then these are the rings I have to use. So I checked the measurements both on ring 1 and ring 2. So ring 1 actually comes in at 1 millimeter. And ring 2 comes in at about 1.4, 1.3. So what I wanted to see is that the rings out of this piston have the same measurements. Otherwise we can't use those rings. So when checking ring 1, it also comes in at 1 to 1.0 millimeters. So top ring can definitely be moved over. The second ring on the bad piston was 1.3, 1.4. And on the piston we want to use, it's actually 1 millimeter. So that second ring isn't going to fit in the good piston. So we need a new set of rings, which means we need to hone the cylinder and clean the block again. So I actually do have a new set of rings that were not used for another project. So I was double checking these, and I think we're going to be okay. Ring number 2 was the one in question, and when I measure it here, we're at 1 millimeter. And if I check the top ring, that also should be 1 millimeter, and it is. So this new set of rings I think will be fine. We are going to have to check and potentially adjust the end gap. So yeah, let's check the end gaps now on these, and then I'm thinking we will loosely assemble things and just make sure that everything is going to work out as it should. All right, let's check the number 1 ring first. That gap looks pretty good. I would say it's probably around a 15 or a 16. So let's start with the 15. That fits. Let's jump to 17. 17 fits, but it is quite tight. So I'm thinking it is a 17. Let's check an 18. Yeah, 18 doesn't fit. So the top ring should be fine. If it was less than, I'd say 11, I'd be very concerned. But the way it is good. Let's check the second one. And that gap looks a little bigger. Let's try a 20. Yep, 20 does fit. And 23 does not fit. So it's probably around a 21, which is fine. The second ring gap is usually a little larger than the first. So I think these rings will work. It probably doesn't matter, but I'm going to use the original connecting rod. Since that has been running on that crankshaft, it should be mated well with it already. So we're just getting out one circlip, and this wrist pin should, I say should, slide out. Might need a socket of the right size to tap that through. Just make sure it's in the groove, or else the engine isn't going to run for very long. Yeah, I think we're good. I think we're good. The skirt of the piston, it's shaped to clear the counterweight. So I think we're good. I'm just going to add the camshaft to make sure nothing interferes with that. I think we're good. And that is perfect. We are at top dead center. And the piston is in the right spot. So, I think we can hone the cylinder, get the rings installed, and put this thing together. Now, this cylinder doesn't need much, so it's just going to be a light, quick hone. I've already got the oil expander ring installed, and now I'm going to put on ring 2, followed by ring 1. Now, these didn't come with any instructions as far as indicating which ring is which and which side is up, but it does matter. And the rule of thumb is that if there is a marking on the ring, like we have there, then that should be facing up. And the ring that has the chrome, sometimes it's all chrome, in this case, it's just a chrome corner, that is the top ring. So we'll start just by getting the second ring on. And then the top ring. And that's it. The piston is ready. The rings are clocked. I have the top one over to the right, the second one 180 degrees to the left, and then the bottom expander ring, that's actually 3 rings. And those I have staggered. So the center of the expander ring is right there, and then we have the top and the bottom ring about 20 degrees offset from that. So the piston is ready. I say we get that installed. We'll put the bottom end together, get that closed up, and then move on to the head. I put a little bit of thread locker on these bolts that hold this oil sensor in place. I don't have a manual on this engine. When in doubt, this is a clone of a Honda GX390, so using Honda specs should be pretty safe. You know, Honda calls for 120 inch-pounds on the cap, so that's what I'm going to do. I'm going to bring it up halfway and then finish it off. All right, we need to line up the timing marks. There's one right there in the small gear, and the other one is right there. So we are off. And that is perfect. And on the counterbalancer, there's a timing mark right there, and that's going to align with the one right there on the larger gear. Like that. We're getting close. And it's tempting just to install the head. I'm sure the valves are seating fine. I don't think this head had a whole lot of hours on it. But since we have access, let's decarbon this. You know, we'll pop the valves out real quick, lap them in, and of course, clean up this surface. Yuck. That's oil. That's pretty nasty. So, yeah, I might change my mind on this one. This was the cleanest head from the outside, but the engine that this came from was not in good shape. I don't know if you remember it, but I think it was a GP5500 where the oil down in the sump was probably the worst I'd ever seen. And I thought the top survived, but yeah, I mean, this could be cleaned up for sure, but I have a few others to pick from. So I think I'm going to set this one aside. We'll choose a better one. All right, head number 2. This one isn't bad, actually. It'll clean up really well. But let's get the valve cover off and just make sure we don't have any surprises. Better. A lot better. So before I lap these valves in, I'm going to clean them real quick, just with some Scotch-Brite and a bit of WD-40. Spin it in the drill and just let the Scotch-Brite do the work. Yeah, the intake valve feels pretty good, so it only needs a tiny bit of lapping. It looks pretty good. We got a nice line going around. And a quick test is just to drop the valve in and put some light pressure on it. Try to spin it. It shouldn't spin. If it does, you might lap it just a bit more. In this case, the intake is fine, so we'll get that out and do the exhaust. The exhaust valve lapped in real good. And unlike the intake, the exhaust did spin pretty easily before the lapping. And now it sits in there pretty well. So let's get the valve springs back on and bolt this to the engine. Make sure the flat side of that retainer faces down toward the rocker. Not sure what to think of this gasket. Usually I use ones like this. And, well, the kit I ordered came with a metal one. So we'll give it a try. Worst case, we can always swap it out. Yeah, we're at the point now where I'm getting excited to hear this engine run, so I'm going to put some oil in now before I do something stupid and try to start this engine without any oil. And this is just 10W30 conventional. You don't want to use synthetic until the rings have seated. I want to get the push rods in next and set the valves, but first we'll do the flywheel and probably the ignition coil. It'll just make it a lot easier to rotate the engine to top dead center. With ignition coils, technically you can mount it either way and it will go on just fine, but if you mount it the wrong way, it may not spark and the timing will be off. You know, in this case, it's not labeled which way is which, but on Hondas and Honda clones, this kill tab faces down. So that is kind of the dead giveaway. So we'll just connect the wire, attach it to the clip, and then we'll secure it with 2 bolts and then set the gap. So I need to torque down that flywheel nut, and I want to do it now before I install the push rods, because without the push rods, the valves are always closed. So right now the piston's at the bottom of its travel. We're just going to fill the cylinder with rope, which will lock it up, and then we can torque down that flywheel nut. Now, I have some conflicting information as far as what the torque should be. You know, I saw one Honda article that said 83 foot-pounds. Another one said 125. And I also checked the Rato service manual, and they say 98. So I'm going to go with 98 because my torque wrench tops out at 100. So 125, not an option. swapping that head from a Hemi to a standard definitely isn't as simple as just that. As we've already seen, we had to swap the piston as well. In our case, that worked to our favor because that was the only piston type we had was for a standard head. Now we're at the point where we need to get the push rods in, and looking at the push rods that came with the Hemi head, they're quite a bit longer than the ones on the standard, which is on the right here. So I'm assuming we're going to need these push rods rather than the Hemi push rods, but let's just test fit one of each to make sure. This here is the longer push rod from the Hemi. And yeah, I think that is too long. Let me just rotate the engine, make sure the tappet is closed, and it is. So when it's closed, this rocker, if anything, should be level with the surface, if not tipped back a little. And in this case, we're already tipped forward like it's trying to open the valve. So when the valve actually opens, it's going to continue quite a bit further in that direction, and the angle is going to be too steep. So the Hemi push rods, I think, are out, and we'll stick with the shorter ones. The geometry looks pretty good, but I realized I forgot something. And this is something that I think a lot of people forget or don't even know about, and that's the rotator cap. Not all Hondas and Honda clones have it. Some of them have no rotator cap. Some of them have just one on the exhaust, like this one. And some have a cap on each. And the sole purpose of it actually is to put a little bit of air gap between the valve stem and this rotator cap. So when the rocker actually pushes down, it's pushing more on the retainer, and the valve is allowed to float a little bit in the retainer, which loosens it up, and then it can rotate, minimizing wear to that valve. Yeah, the easiest way to adjust valves on this engine, or really any engine, is just to rotate the crank until one of the valves is open and the other one should be closed. So at that point, you can dial in the gap that you need. In this case, I'm aiming for 7 thousandths. So we'll get it close, which is right there. And then I'm going to add this nut right here. This is what locks the adjustment in place. You basically tighten these two against each other, and then neither one will rotate. But as you tighten them, it takes out kind of the slop in the thread. So even though we're right at 7 now, once I tighten this, usually that gap will close. So what I like to do is snug these up, which will take out a lot of that slop. When I say tighten, just snug them so that you can actually still make adjustments. So right now, while we were at a 7, and see now a 7 no longer fits. So we'll back that up a bit. But you see when I do that, actually this nut didn't turn, so it is kind of locking up. So I can only turn it so far before I can't turn it anymore. And actually that is pretty much perfect. So let's just make sure it's snug. And by snug, I mean tight. And yeah, that one is good. So rotate the engine till the exhaust is fully open, which is right there. And then the intake, I'm going to set to 5 thousandths. And same procedure here. That feels pretty good. Yep. Now we lost our clearance. I'll back that up just a bit. And both nuts are spinning, so it's not going to lock us from making the adjustment like the other one did. All right, it's too tight. Feels pretty good. And there was a lot of slop in there. So I'm willing to bet it's tight again. Yeah. There's actually 0 lash right now. Perfect. Another side effect of swapping the head is that the tins, both the top and bottom, from the Hemi head don't fit. You know, we have to use the standard tins. And I think even the blower housing, it's a little bit different in this area. So we're going to have to swap that out as well. Spring tension feels pretty good, but I don't want this running at 3,600 RPM, at least not to start with. So I took some of the tension off. It might take a little bit more. You know, I'd rather start this at a lower speed, and once we're sure things sound good, we can bring the speed up some. As far as the wiring goes on this machine, it's pretty straightforward. We have this wire right here, which runs over to the ignition coil. If this wire is grounded out on any part of the engine, then spark is killed and the engine shuts down. So we have two switches to essentially connect this wire to ground. The first one right here with two wires, one is connected to ground, and the other one we need to connect to the coil. And like this, when we turn the switch off, it'll kill spark. And the second switch is inside the engine. That is the low oil switch. The yellow wire comes out, connects over to the low oil module. Now we have a black wire coming out, which is what actually kills the spark. So we're just going to connect that into the same circuit. So now either one of these can shut the engine down. We're getting pretty close. Just fuel and exhaust. So I dug around in the carb bin, came across this one I labeled good. So I think we have a winner. Now this carb isn't perfect for this engine, meaning we have a fuel solenoid. This engine can't control it, but it doesn't matter. This is normally open, so the fact that we can't connect the wires shouldn't impact its performance. And the second issue is this choke is for an auto choke, which again, this doesn't have. So we're gonna have to control this manually, but the rest of the carb should work just fine, at least for testing. So before just bolting this on, I want to double check the governor calibration because this head is a different size. And the governor was calibrated for a different head, which likely means the carb was in a different position. So the way to double check this is to set the throttle plate in wide open throttle. Keep it in that position, slide the carb into position, and then move the governor arm in the same direction. Now, the spring is already holding it in wide open throttle. That's idle, that's wide open throttle. So like that, both of these are wide open throttle, and the 90 degree on the rod should align with the hole here where it installs. And I think you can see the problem here. We're a good, inch away. So if I were to install this as is, the governor would not be able to slow this engine down. It would just run at wide open throttle until the engine blows. So we need to loosen this nut, reset the governor calibration, and then finalize the carb install. And just make sure you have that pin on the governor shaft. Without it, you could get yourself into trouble because when you loosen this nut up, the only thing keeping this shaft from falling into the engine is that pin. And it actually rides on the outside in a channel on this shaft. So if you push down hard, once this is loose, you could actually pop the pin off and then the shaft falls into the engine. If that happens, the only way to get it back is to open the engine and retrieve it. That is on there tight. There we go. The other thing you need to figure out here is which way does the shaft move? Which way does it rotate when moving to wide open throttle? So when I move the throttle plate and the arm to the right, this shaft rotates counterclockwise. So that is important because once we connect this to the carburetor, we want to hold the arm in the wide open throttle position and at the same time rotate as far as we can to the wide open throttle position, which is in this case counterclockwise. Well, I hate to say it, but I think the adjustment I just made may not have been absolutely necessary. Now that it's been made, I can see things operate fine. But in the wide open throttle position, this arm is usually coming more straight out, and instead we're at an angle. So that got me wondering, is this rod shorter than standard clone rods? And the answer is yes. The Hemi governor rod is shorter than the standard head rod. So I'm actually going to put the correct part on. We'll reset things again and move on. This anti-surge spring, it is kind of bent up. It should be replaced. I've got some on order, but for now, it'll be fine. As long as it applies some spring tension, it doesn't matter the shape of the spring, it'll work just fine. So now that we have the engine back together, I'm going to do a quick compression test. This has a decompression system, so 60 psi is usually the average that I see. That could be plus or minus 10 psi, so anywhere between 50 and 70 would be perfect. So let's pull the engine over and see where this one comes in at. Beautiful. And we're at 70 psi. So this engine should run quite well, I would think. So let's add the plug, bit of fuel, We'll see if it starts. So what do you think? Is it going to run? I think so. But I've got to admit, this makes me a little bit nervous. I have never done a Hemi swap to a standard head, and I've never seen anyone else do it. So, although I think I did it right, until it runs, we won't know for sure. So to that end, I've plumbed in the fuel. It's turned on. We don't have any leaks. So let's close the choke, turn on the ignition, and we'll try to start it. Now, assuming it does start, the engine speed is going to be a little bit slow. I did take some of that tension off. So if the engine sounds good, we'll increase the tension a bit and just see how it does. I've got to admit, this one exceeded my expectations. I went into it not knowing if it was possible to do a Hemi head swap with a standard head. And of course, as we just saw, it is possible because this engine, it is running quite well. It started first pull. I was able to turn the choke off right away, and the engine sounded great. No knocks, no funny noises. It was running nice and smooth. So I brought the speed up close to 3,600 RPM, and things kept running just fine. So considering where we started, this was a blown up engine with a hole in the piston, a damaged, unusable head with a broken valve and likely a bent valve. And of course, if we wanted to fix this correctly using Generac parts, it would have cost $500. And instead, we pieced together a machine with the parts on hand, for the most part. I did have to buy a gasket kit. That was $14. And of course, the set of rings. That was $20 from eBay. So in total, I had $34 in parts and a bunch of time. And the end result, well, I'd say it turned out pretty well. So I guess the question is, can it pull a 6,500 watt load? This is a 13 horse engine, and that's something we're not going to find out today. I don't have a Honda clone that needs an engine right now. So this engine's going to go on a shelf, but you will see it again, hopefully soon. So I hope this video helps someone. Thanks for watching.